Hello everyone, I'm Amulya, Assistant Professor in Department of Electrical and Electronics Engineering, Sai Vidya Institute of Technology. In today's session, I'm solving the fourth problem on Module 2. So this is the given problem. You can observe that a synchronous motors, both are identical motors. This has been connected to the large system with the help of a transmission line, and the rating of the various components, that is the rating of the motor, is given as 1 MVA, 440 volt, 0.1 per unit, and the reactance of the line is 0.05 ohm. One important thing here you have to observe is, so the motor ratings, the power is given in MVA, so that means the voltage should be in kilovolt only, because it is expressed in a three-phase base, means the voltage also should be in a three-phase. So now what we can do, before proceeding with the calculation, we can convert a 440 volt into kilovolt, so that I can write the values of the motor as in terms of kilovolt as 0.44 kilovolt. So remember, the power and the voltage both should be in a single phase or in a three phases basis. One in the three phase, other one in the single phase, it cannot be considered. Next is the large system which is having a short circuit MVA at its bus having a 440 volt is 8. So here they have given the motor operating at 400 volt. So that is nothing but, so they have given the rating of the motor. So this is, we can consider as a pre-fault actual value. So as a 400 volts. So only on the load side they have given the actual value of the voltage, but the current value and the power value, it is not given here. So you have to calculate the short circuit current fed into three-phase fault at the motor. So that means you need to calculate the fault current in actual, IF double dash actual. So this is what the given problem is. So one important thing you have to observe. So here, usually in the previous problem, there will be a generator is there, that is connected to the system, and then we have a load will be there. But here there is a change. Instead of generator, we have a large system is there. So what is the meaning of a large system means? The large system may be treated with an infinite bus. So remember, large system means we can consider this as an infinite bus that is supplying the power at a constant voltage source. Okay, consider the large system is an infinite bus that supply the power at a constant voltage source. So now based on this assumption, we'll proceed for the solution. So in the problem, they have not given which component to be considered as a base. So the large system ratings, it is not given properly. So the next connected is the line, only the reactance is given. After that comes as the motor. So what we can do, the motor ratings we can consider as a base, that is 1 MVA and 0.44 kilovolt. So these two rating will be the base MVA power new and base kilovolt new. Now considering this, we'll proceed with the step. First step, converting the given single line into a per unit reactance diagram. So MVA base new is equal to 1 kilovolt base new will be the motor base voltage 0.44 kilovolt, because the other component values are not given here. We can consider the motor rating only, the base value, and there is no change in voltage will be takes place, because the single line diagram, it is not having a transformer. If there is a transformer comes, then only the change in voltage will be takes place. So now directly we'll proceed with the reactance calculation. So the per unit reactance calculation of motor M1, so both the motors having the same ratings, M1 and M2. So we'll proceed with the calculation. So X per unit new of M1 M2 motor will be, so X per unit volt given in the problem is 0.1 multiplied by MVA base new is 1, volt is also 1, and the base voltage volt is 0.44 and new is also 0.44. So that will get the answer for the motor is 0.1 per unit. Similarly, we'll do it for the transmission line. We have one transmission line is there. Per unit reactance of transmission line. So that is equal to, we can write X per unit new of the transmission line. See, observe here the transmission line value, it is given in ohm. convert this ohmic value into per unit value. So we can write J 0.05 multiplied by, you know the formula for the ohms into per unit conversion, MVA base nu, that is 1, then kilovolt base square nu, same motor value only applies to the transmission line also, 0.44 whole square. So we'll get the answer as J 0.25 per unit. So after that we can proceed with the per unit reactance diagram because all the calculations are over. So here I have drawn the per unit reactance diagram. So remember, large system is nothing but it is an infinite bus that feed power to the entire system with a constant voltage source. So this is the reactance diagram. So this completes step 1. So next proceeding with the step 2, that is calculation of VPF. So now one important thing you have to observe. So they have given the details of only VPF, that is actual value 400 is given, but they have not given the value of the power, and also the power factor is not mentioned. So without the value of power and power factor, IL calculation cannot be done. So now based on this, we'll proceed with the step 2. So this is the pre-fault voltage calculation. VPF actual, it is given in the problem. As I told you, it is 400 volts and the base value will be the motor value, it is 0.44 kilovolt. So same we will write, and even here also before considering this is expressed in terms of voltage and convert this into kilovolt, so that we will get 0.4 kilovolt. So same way I'll consider here. This is 0.4 kilovolt divided by 0.44 kilovolt, that is the base voltage of the motor. So after dividing, we'll get the answer as 0.909 per unit. So this is a VPF calculation. So next is IL calculation. So for the calculation of IL, we have the formula as IL actual divided by base. Now let us consider the actual formula. So it is P divided by root 3 into V cos phi, and at an angle of cos inverse of phi will be there. But in the problem, only they have given the value of VPF actual, that is voltage actual is given, only this is given. So they have not given the details of P and also cos phi. So that is why we can directly consider this IL value will be equal to 0, because the power and the power factor, it is not mentioned in the problem. So now the step 2 is completed. We'll proceed with the step 3, that is fault current calculation by using the Thevenin's theorem. So in this fault current calculation, we know the formula IF per unit will be equal to VTH by ZTH. So VTH is nothing but the V pre-fault value we calculated in the previous step. So directly we can write VTH will be equal to VPF in per unit, that value is 0.909 per unit. So next is to find ZTH value. So for that we have to consider the same reactance diagram which I have written in the step 1, but here the large system need to be considered as a closed circuit, and also we need to neglect the source voltages. So the same reactance I am going to write it once again for the ZTH calculation. So here you need to see that the three-phase fault, it occurs in between the transmission line and the motor, that we have to represent in our single line diagram also, that is in the reactance diagram. So this is the occurrence of a three-phase fault. So now for the ZTH calculation, consider this as a closed circuit. Next we have one reactance, then we have two motors are connected in parallel. So this is how we can represent the given system, and here indicate that this is the point where the three-phase fault has occurs. Three-phase fault. So the reactance of this is J0.25, this is J0.1, this is also J0.1. So you know that the simplification and for the calculation of ZTH, so here J0.1 and J0.1, these two are in parallel. So now apply the parallel formula and we can write the final simplified network as in this way. So this is J0.25 as it is, and this is writing the parallel formula for J0.1 and J0.1. So we'll get J0.05, and this is the point where the three-phase fault has occurred. So now for the calculation of Zth, it is understood that J0.25, this reactance is in parallel with J0.05. So that we'll get the Zth value as, I'll do the direct answer, 0.041 per unit. So this is Zth calculation. So now we can substitute this answer in the IF value or IF formula. Vth is 0.909 divided by Zth is J0.041. So after substituting this, we'll get the answer for the fault current as 21.8 at an angle of minus 90 degree per unit. So this is what the required answer. But the final answer, it is supposed to be in amperes, nothing but actual. So what we can do, we will proceed with the last step, that is step 4, that is calculation of actual fault current value. So the last step is actual fault current calculation. So already we have got the answer for the fault current in terms of per unit. So this is to be converted in terms of actual. So we'll write the formula. IF actual will be equal to IF per unit multiplied by I base. So IF per unit means this answer 21.8 at an angle of minus 90 degree multiplied by, you know the formula for the base current, P base divided by root 3 into V base. P base is nothing but the step 1 value, MVA base 1, and V base is nothing but, since the fault has occurred on the motor side and we have only one base value only, so this only we'll consider. So now P base is 1 MVA, 1 into 10 power 6 divided by P base is root 3 into 0.44 into 10 power 3. So after the calculation, we will obtain the final answer for the fault current actual. See, actually this is subtransient value. So we'll indicate this as IF double dash as 28,616.9 at an angle of minus 90 degree. So this completes the given problem. Thank you.